just a little introduction. This program is designed to challenge engineering students' ability to program a blinking rate of an LED light using circuits. For this experiment, you will need access to the Arduino programming board, one LED lights, one resistor, one breadboard, and 2 jumper wires. Here are the instructions for how to properly complete this experiment. You must insert the longer leg of the LED, that being the anode, which is this guy right here, into its own breadboard row, and place the resistor right next to it. The anode is the positive side where the current enters the LED lights, and you need the resistor to prevent the overflow of electrical currents to the LED so that it doesn't burn out or worse, explode. Step 2, you must connect the other end of the resistor to the breadboard row, assuming that they share the same electrical connection. This is because the components of a breadboard row all contain the same currents, and if you don't plug in the other end of the resistor, the electricity isn't going to flow anywhere. So in order for the resistor to actually be effective in its job, it must need somewhere to flow. Thus, you need to place the other end in the same row that you placed the first end in. Step 3, you must insert the shorter leg of the diode, which is called the cathode, which is this other little guy right here, into its own separate row on the breadboard row. This is because the shorter side, or the cathode, is the negative side of the LED, and it's where the currents flows out and back into the board, completing in a way completing the circuit and allowing the blinking light to turn off and on again. Step 4, you must connect your desired jumper wire into the breadboard and then to the motherboard right here. This is because this is the path where the electricity from the motherboard will flow into the breadboard, controlling the resistor and the LED light. Step 5, you must connect the step 5 sort of goes hand in hand with step 4, and that is placing the other end in your desired number bin in the motherboard. This is because in the actual Arduino code, you must type in which board number you want in order for the code to run on the motherboard properly. The final step is to place your other end of the cathode, of the wire. The final step is to connect the other wire from the breadboard to the Arduino grounds program, which is labeled G and D on your board. This allows for the Arduino program to be processed within the motherboard and then transferred throughout the breadboard and the motherboard. Now we are going to go to the code and explain that. Hello, welcome to the Arduino Blink program. This program allows for the controlling of the blinking rate of this LED bulb right here through this code, travels to this motherboard, and the wires deliver the codes and messages into the circuit board, which allows for the bulb to light. First of all, this inlet lead pin number 7 equals 7 allows for the transfer of the codes to the board through these two wires. This high digital write code turns the bulb on, and the first delay function for 1000 microseconds or milliseconds leaves the bulb on for 1 second. The lead pin low digital write function turns the bulb off for 1 second, and the delay in the second delay 1000 milliseconds leaves that bulb off for 1 second. Now, if you wanted to change that, we easily can. We changed it to 100 millimeters, and we uploaded it to computer through the arrow. Now it's going to blink rapidly because we decreased the delay time from 1 second to 0.1 seconds. If you want to increase it, we can do it this. We can add to it, making it 10,000 milliseconds or 10 seconds. As you can see, the bulb is going to stay on for much longer, and then it's going to turn off here in a minute, and then it's going to stay off for around 10 seconds. Now you don't just have to keep them the same, you can switch them around. For example, we can make this 3000, we can make this 2000. So we increased both, but we increased the time the bulb was on to 3000 milliseconds or 3 seconds, and we increased the time that's off for 2000 milliseconds or 2 seconds. And as you can see, the bulb is going to stay on for a slightly longer time than it is off. But we can also switch them around the other way. Now we've switched the program. We've increased the second delay function for the bulb being off to 4000 milliseconds or 4 seconds, meaning it's going to stay off longer because the second delay time is higher than the first delay time, which keeps the bulb on for 2 seconds, because we increased the millisecond delay to 2000 milliseconds. So those are just a couple of ways that you can alter your bulb program to make it more interesting and give it a bit more variety. Thank you for listening.